In the coming sessions, we're going to learn something about the laws of motion. It is all about Newton's 3 laws of motion. Forces will be defined in its relation to the Newton's laws of motion. Forces and their several types and the meaning of equilibrium will be understood. You're going to get some knowledge on the 3 laws of motion. Also, you're going to see several examples of forces and the role of each force in doing equilibrium or making non-equilibrium cases. Also, we're going to see what a force of friction differs from a typical force, and what is the role of friction in our life. Several examples. Several applications on Newton's second law will be given, and several problems will be solved. Going to differentiate between the true weight and the apparent weight. What is Newton's first law? Actually, in Newton's first law, stated as follows: an object at rest or an object in motion at a constant speed will remain at rest or at a constant speed in the absence of a net force. This is also called the law of inertia. To get a deep understanding of the first law of Newton, now if the object is at rest, it remains at rest. This means that if the object has a velocity of 0, it means the net force on it is 0 and is not moving. So as long as there are no external forces will change this state of motion, so the state of motion of the object will remain at rest. Now, if the object is moving with a constant speed in a certain direction, obviously, if the net force on it does not change, it continues to move in its motion with the same velocity. When there is no force is required to keep a body moving in a straight line, where the effects of forces like friction are negligible, then the body will be kept in its state of motion, as we mentioned above. When we say an object is in translational equilibrium, this means that the net force acting on it is 0. What do we mean with the net force acting on it is 0? If you have several forces, and the force here will be defined as a vector quantity, and the addition of these forces is in accordance with the addition of vectors. This means that if you add all these forces as vectors together, you're going to get an answer of 0. Again, a force is a vector quantity. Like any vector, can be represented in 1 dimension or 2 dimensions or in 3 dimensions. In all cases, when we said the net force is 0, it means the body or the object is in translational equilibrium. Translational equilibrium is classified into two. So the body could be in static equilibrium. What does static equilibrium mean? It means that its velocity is zero, and obviously its acceleration is zero. The other type of translational equilibrium is the dynamic equilibrium. What do we mean with the dynamic equilibrium? And what's the difference between this kind of equilibrium and the previous one? Well, in this case, the velocity is constant all the way in its motion. Obviously, when the velocity is constant and the derivative of the velocity is the acceleration, so we'll get an acceleration of zero. So there are two cases in which the object could be in equilibrium. In both cases, the acceleration is zero. When we said the acceleration is zero in these two cases, this means that the net force acting on it equals zero, as the force is the product of the mass of the object and the acceleration. Again, this object is in equilibrium. It is at rest and it will remain at rest. And this object is at equilibrium because the net force acting on it is zero. This means in every single piece of these, every single piece can be tested, and we can find that the net force acting on each piece is zero. Then the whole system is in static equilibrium. Trying to understand the first law of motion, let's see here. A block is placed on a sheet, and the sheet is pulled quickly to the right. Then, in this case, we'll see that the block tends to remain at rest while the sheet is moved away from it. Now here you can see that when the sheet is pulled quickly away, the block tends obviously to stay at rest at the position where it was previously. Now, what about if the block and the sheet move together at a constant speed? What will happen if we intended to stop the sheet suddenly? We will see. As you can see, the block is trying to keep itself moving with the same previous speed. Try to look at this picture if a driver is moving with a velocity and starts to accelerate from rest, and all of a sudden, if he applies the brakes, then in such case the driver is forced to move forward, because an object at rest tends to remain at rest, and the driver must resist the forward motion as the brakes applied. A moving object tends to remain in motion.
We'll try to remove the tablecloth from under these dishes without making a mess. How? By yanking the cloth out very fast. Pull slowly and the table setting moves. This will have to be done much more quickly. A metal tube wrapped inside the loose edge of the cloth provides a firm grip for a fast pull. When the cloth is yanked out fast, the dishes barely move.
Could you remove this pizza pan from under these eggs without touching or breaking the eggs? If the eggs could be made to drop straight down, they would land in these water-filled beakers and would survive intact. By striking the pizza pan hard with this broom handle, the pan will fly out, allowing the eggs to drop straight down into the beakers. Let's try it. The pizza pan shot out so fast that the eggs barely moved. Let's watch again in slow motion.
Now, the question we might ask, do you learn anything about the first law of motion? Well, the answer is yours.